Okay, now we're going to look at solving a right triangle, which means finding all three sides and all three angles. And in order to do this, actually for this one we won't need to, but in the future we're going to be using what's known as the inverse sine, inverse cosine, and inverse tangent. And I'll show you how to do that in just a little bit. For this one, first of all, we can find angle B. Let's see what we do have. We have angle A, which is 42 degrees. And we know angle C is 90 degrees. And what we want to find is angle B. Also, we don't have AB. We don't have BC. But we do have AC, which is 70 feet. So we need to find all the parts that are missing. So it's probably a good idea to write this out at the beginning, just so you make sure you have everything. Now, angle B is the easiest thing to find. And there should be measures here, sorry. If I want to find the measure of angle B, I know these three angles add up to 180, or angle A and angle B add up to 90. So therefore I can say that the measure of angle B is equal to 90 minus 42, which ends up being 48 degrees. So we have that. So this is 48 degrees. Now we want to find AB and BC, and you had a problem similar to this in your homework where they asked for the perimeter. What we need to do is find one of the two sides, either using sine, cosine, or tangent, and then we can use Pythagorean theorem to find the third side. So I guess I'll use tangent to find BC. So we know tangent of 42 degrees is equal to, we'll call this x down here. So that would be x over 70, multiplying both sides by 70. The 70s cancel, and we get x is equal to what this is. Remember, we're rounding to the nearest tenth here. So I'll need my fancy calculator. We're going to do 70 times tangent of 42. Oops. And we get 63.1. So that is, for BC, it's 63.1 feet. And now we can use, actually, you know what I'm going to use instead? Because I don't like working with decimals. I'm going to use, since this is adjacent to 42 degrees and that's the hypotenuse, I'm going to use cosine. I would suggest as little as possible to use numbers that are rounded. So cosine of 42 degrees is equal to, we'll call this side y. So that would be 70 over y. I'm going to multiply both sides by y. And those cancel. We get y times cosine of 42 degrees is equal to 70, and we divide both sides by cosine 42. The cosine 42's cancel, and we get y is equal to 70 divided by cosine 42. So I'm going to use my calculator, and I get y is approximately equal to 94.2. So up here, 94.2 feet. And this is solving a right triangle. We know all of the sides and all of the angles. So I'll show you again. They may have done it slightly different. That's okay. Finding the angle using triangle sum theorem. Again, they went the long way. You could have just said 90 minus 42 there. For the next part, we're using tangent. They did what I did to solve for BC. And multiplying that out, we get about 63. I think we got 63.1. We're going to use cosine, so they did do what I did. Good. So that's 70 over, we said y, multiply both sides by AB, and then divide both sides by cosine 42. Again, try to avoid using decimal numbers when you can. And we get, calculating it out, 94.2. So that gives us all three angles and all three sides. Here's another problem using what's known as a rake stage. Basically, they tilt the stage so that you can see everything that's on the stage if you're sitting in the audience. We want this angle to be 5 degrees or less. So if you notice, we have two of the sides. We can find the angle. This is where we use inverse sine or inverse cosine or inverse tangent. And I'll show you how that's done. We'll go to the next page. Well, actually, we'll stay on this page. So basically, right now, we know that the sine of x, I'm sorry, we don't want to use sine. Yeah, we do. Sine of x is equal to the opposite, which is 2 over the hypotenuse, which is 30. And we could also write that as sine of x is equal to 1 over 15. Now, if I want to know what the angle is, what I have to do is switch these around. And when I do, we rewrite this as the measure of angle x is equal to, and we write sine with a little -1 here. That's called the inverse sine. And that's what we get. Now, if you look on most of your calculators, there should be something either above the sine button or nearby it that has this -1. That's for the inverse sine, and we use it to find angles. So I'm going to do that on my calculator, and you should do it on yours to get the practice in. So let's see, does it have it on mine? Should. For some reason, I don't have it on mine. Oh, I have it right here, sorry. Okay, so we're going to do inverse sine, inverse sine of 1 divided by 15, and we get approximately 3.8 degrees. Now, if you notice, we want this to be 5 degrees or less, so therefore we know that this is within the boundaries, so we're okay. So again, what we do is we take the sine is 2 over 30. I would just write it as 1 over 15 rather than writing it like this. And so we do the inverse sine of that. We get 3.8. So we end up being okay. So it's within the range. Now we have two more. We're going to solve a right triangle where we have a 40-degree angle and a 20-inch hypotenuse. You would draw this picture if you got a problem like this, and you would solve everything. I would just label it ABC, just so you know what's what. So we have a 40-degree angle here and 20-inch hypotenuse. So first we know measure of angle A. We don't know. Measure of angle B is 90, and measure of angle C is 40. So hopefully you can figure out that this is 90 minus 40, or 50 degrees. We don't know AB. We don't know BC. But we do know that AC, in this case, is 20 inches. So, things that we have figured out so far, we figured out that. We need to figure out this and this. Again, what I would do is label this X and label this Y. This time, if I do opposite over hypotenuse, that is sine. So I'm going to say sine of 40 degrees equals X over 20. If we multiply both sides by 20, those cancel, and X is approximately 20 times sine 40 we should get 12.9. Oops. If we round. So that would be AB, so that's 12.9 inches. Now we're going to do cosine for BC because it's adjacent over hypotenuse. So we say cosine of 40 degrees equals y over 20. Again, multiplying both sides by 20. The 20s cancel, and we get y is approximately 15.3. Oops, so we have 15.3 inches here. So we have all of our things that we needed, the 50 degrees, the 12.9, the 15.3. There we go. We're set. Now we want to know if the stage is 20 feet long from front to back and the rise is 2 feet, if that is good enough. So we're going to do it again. If you remember, the picture for this looked something like this, where this was x degrees. We're told this is 20 feet and this is 2 feet. So we know that the sine of x is equal to 2 over 20 or 1 over 10. Therefore, if I want to find the measure of angle x, I'm going to do the inverse sine of 1 over 10. So, get my handy dandy calculator, make sure you do inverse sine, not sine, and we do that for 1 over 10. If we do that, we get 5.7 degrees, and we would say the stage is not safe. Because it's over the limit of 5 degrees or less. Okay? And it's slightly larger than the suggested range. Exactly. And that's it. Thank you.